Hello students, welcome back to our video lecture series for the subject Mathematics 3 for all my mechanical engineering students, myself Dr. Ankit Acharya, and today we will discuss about our very new chapter, Roots of Algebraic and Transcendental Equation. So in this chapter, majorly we have four methods. First one is a bisection method, then regular Palsy method, then Newton-Raphson method, and secant method. Okay, so we will discuss about this four method. So first one is a bisection method, which is very basic method of to find roots of any algebraic or transcendental equation. Okay, so basically in this chapter we can find the approximate roots of any algebraic or transcendental equation. We know that because every polynomial does not have exact root, we cannot find. Okay, we know that suppose x square minus 1, that is equal to 0, so we know that x minus 1 and x plus 1 factorization is possible, and 1 and minus 1 are roots. Okay, 1 and minus 1 are roots. Clear? But every time every polynomial does not have exact root, or we cannot easily find. Okay, so in that case we are using our numerical methods. Okay, to find approximate root of that algebraic or transcendental equation. Okay, so let's see how work bisection method. This is a bisection method. The theory is not important for exam point of view, just try to understand what it says. Okay, so first one is a bisection method, right? So this is a figure. This, see, alpha is a exact root. Okay, alpha is exact root. Okay, so let f of x is equal to 0 be the given equation. Let x0 and x1 be two real root, okay, of x at p and q. So basically what we are doing here, that in bisection method, suppose f of x is equal to 0. Okay, this is my algebraic equation or transcendental equation, and I want to find the approximate root of this equation. So first we find x0 and x1 such that, okay, such that suppose f of x0 greater than 0 and f of x1 less than 0. Okay, we just find x1 and x0 and x1 such that f of x0 greater than 0 and f of x1 less than 0. Then definitely your one root lies between x0 and x1. So let's say x2. Let x2, that is equal to x0 plus x1 divided by 2, average of x0 and x1. Now find f of x2. Suppose f of x2 greater than 0, then you have to take at which point function is less than 0, above. So f of x2 greater than 0, but here you can see that f of x1 less than 0. Okay, f of x2 greater than 0, but f of x1 less than 0. So now your root lies between x1 and x2. Okay, root lies between x1 and x2. So that's why x3 is equal to x1 plus x2 by 2. That you have to take, because your root lies between x1 and x2. And continue this process until you will get almost near by root. Okay, so suppose f of x1, suppose f of x2 less than 0. Now f of x2 less than 0 and f of x0 greater than 0. So that means your root lies between x0 and x2. Okay, root lies between, we can say, okay, or just write down the full sentence in exam. Root lies between x0 and x2. So that's why your next approximation is average of x0 and x2. So x0 plus x2 divided by 2. Okay, so this is case 1, and this is because f of x2 we assume that greater than 0. This is case 2. Suppose f of x2 greater than 0. Okay, and continue this process. Okay, now you can understand this method. See, this is alpha is my exact root. First f of x0, that is less than 0 here, and f of x1. Okay, f of x1 is greater than 0, so f of x0 is less than 0 and f of x1 is greater than 0. So definitely your root lies between x0 and x1, so that's why we assume that our next approximation x2 is what? X0 plus x1 by 2. Okay, now suppose f of x0 and f of x2 are of opposite sign, then your root lies between x0 and x2. So that's why the next approximation, that is x3, that is x0 plus x2 divided by 2. Or sometime happen what, that f of x0 and f of x2 are of the same sign, but f of x1 and f of x2 will be opposite sign. Okay, so that means your root lies between x1 and x2. So your next approximation x3 is what? X1 plus x2 divided by 2. Now this process is continued till the desired accuracy is obtained. Okay, here. So as I explained, so this is my bisection method, and very basic method to find any root of algebraic or transcendental equation. So let's try to solve some important example. Using example you can very easily understand. Okay. So here is my first example. See, find the positive root of x cube minus 2x minus 5 is equal to 0. Correct up to 2 decimal places. Okay, correct up to 2 decimal places means, suppose your x3 is third approximation is 0.3945. Okay, and x4 is 0.3849. So up to 2 decimal places means after point here 39, here 38. So still you have to continue this process. Okay, suppose x5 you will get 0.3856. So now 0.38, 0.38. Okay, after point 2 decimals are same, suppose, then this is your final root. Okay, clear? So the meaning of correct up to 2 decimal places is this one. Okay, now what is your f of x? F of x is x cube minus 2x minus 5. Randomly we are taking 0, 1, 2, 3 instead of x. So f of 0, definitely f of 0 is minus 5. Okay, f of 1. Okay, instead of x just take 1. So 1 minus 2 minus 5. 1 minus 2 minus 5 minus 1 minus 5. So that is minus 6 less than 0. Okay, f of 3. F of 3, that is 3 cube. So that is 27 minus 2 into 3 and minus 5. So 27 minus 6, 21 minus 5. So that is 16 greater than 0. So f of 1 is less than 0 and f of 3. Okay, f of 3 is greater than 0. Let's find out f of 2. Okay, 2 cube. So that is 8 minus 4 minus 5. So that is minus 1 less than 0 here. So f of 2 is negative, f of 3 is positive. So clearly your root lies between 2 and 3. Okay, clearly your root lies between 2 and 3. So my first approximation x1 is average of 2 and 3. So 2 plus 3 divided by 2. So that is 2.5. Now find f of 2.5. F of 2.5 is what? 2.5 whole cube. Okay, you have to find out f of 2.5. That means 2.5 whole cube minus 2 into 2.5 minus 5. Okay, so this equal to almost see this value. You can easily calculate this value using your calci. So 5.625. So this is positive. Now at which point above you will get negative value, because this is positive value. So now you have to find negative value. At which point? Negative value is at point 2. Okay, at point 2. See, f of 2 is less than 0, and now f of 2.5 is greater than 0. So that means your root lies between 2 and 2.5, or you can say 2.5 and 2. Okay, so next approximation is 2.5 plus 2 divided by 2. So 2.25. Now again find f of 2.25. F of 2.25, that is also positive. Okay, you can easily calculate f of 2.25 means 2.25 whole cube minus 2 into 2.25 minus 5. So you will get 1.8906, that is also positive. So at which point you will get negative value in previous. So f of 2, again f of 2. So now your root lies between, because f of 2 is negative and f of 2.25 is positive value. Okay, so now your root lies between 2.25 and 2. So next approximation is 2.25 plus 2 divided by 2. So that is 2.125. Again you will get positive value at point f of 2.125. Okay. So again your root lies between 2 and 2.125. Okay, so 2 and 2.125. So the fourth approximation is 2.125 plus 2 divided by 2. So 2.0625. Okay, now you will see that at point 2.0 or 2 at point 2.0625 you will get negative value. Okay, clear? So now you will get negative value, and where you will get positive value in previous. So 2.125. So now your root lies between 2.125 and 2.0625. Okay, so your root lies between 2.0625 and 2.125. So the next approximation x5 is 2.0625 plus 2.125 divided by 2. So 2.09375. Okay, again you will get negative value. So again your root lies between 2.125 and 2.09375. Okay, so you will get 2.109,375. Okay, so continue this process, right? So the almost positive root is you will get 2.10. Okay, clear? So bisection method is one of the simple method. Sorry. Let's take one more example. Here you can see that find the negative root. Okay, find the negative root of x cube minus 7x plus 3 by the bisection method. Okay, up to 3 decimal places. So f of x is x cube minus 7x plus 3. F of minus 2. Now because we want to find the negative root, so let's try from minus 1, minus 2, minus 3. Okay, so f of 0. That definitely you will get 3 greater than 0. Now f of minus 1. Okay, take minus 1. So minus 1 cube. So minus 1 plus 7 and plus 3. So 10 minus 1, 9. 9 greater than 0. Okay, now f of minus 2. Okay, f of minus 2. So minus 2 whole cube, that is minus 8 plus 14 and plus 3. Okay, so 17 minus 8. So 9. Okay, 17 minus 8. So 9. Sorry. F of minus 2. Okay, so 9 greater than 0. Right? F of minus 3. Find out f of minus 3. F of minus 3, that is minus 3 whole cube. So minus 27 plus 7 minus 7 into minus 3. So plus 21 and plus 3. So that is 24 minus 27. So minus 3 less than 0. Okay, so this is greater than 0. This is less than 0. So now your root lies between minus 2 and minus 3. First one root lies between minus 2 and minus 3. Okay, so minus 2 and minus 3, right, between. So x1 is minus 2 minus 3 divided by 2, average of minus 2 and minus 3, that is minus 2.5. Now find f of minus 2.5, so that you will get 4.875. So of course this is greater than 0, and less than 0 you will get at point minus 3. Okay, so now your root lies between minus 2.5 and minus 3. Okay, so the next root is lies between minus 2.5 and minus 3. So that is minus 2.75. So f of x2, that is minus 2.75, and that will you will get minus minus 2.75. Okay, and f of minus 2.75, that you will get positive value. and again your root lies between, because f of minus 3 is less than 0 and f of minus 2.75 is greater than 0, so your root lies between minus 2.75 and minus 3. So that's why x3 is minus 2.75 and minus 3 divided by 2. Okay. So the final answer is minus 2.875 here. That means third approximation. Okay. And at point f of minus 2.875 you will get negative value. Now your positive value is minus 2.75. So your root lies between minus 2.75 and minus 2.875. Okay, in between, right? So root lies between minus 2.875 minus 2.75. So x4 is minus 2.875 minus 2.75 divided by 2. So this value. So f of x4, that is minus 2, f of minus 2.8125. So minus 4402. Since this is positive value, okay, and previous f of minus 2.875 you will get negative value. So again your root lies between minus 2.8125 and minus 2.875. So definitely your root lies between minus 2.8. Final answer is minus 2.8438 here for x5. Continue this process, okay, until you will get almost same answer. Here you can see that minus 2.836 and here minus 2.8399. Okay, so almost you will get up to 2 decimal, you will get same answer. So this is your final answer for particular this example. So in today's session we discuss about bisection method and we solve some important example. So thank you.